Alright, this lesson is going to be about geometric probability. The objective is I will learn to calculate geometric probability to predict results in real-world situations. Alright, so we're going to do some review real quick. Remember that in probability, the set of all possible outcomes is called the sample space, and any set of outcomes is called an event. Right? If every outcome in the sample space is equally likely, the theoretical probability of an event is this right here. The number of outcomes in the event over the number of outcomes in the sample space. Right, we're going to use what's called geometric probability, which is based on a ratio of geometric measures such as length or area. Right, so I gave you kind of a quick little snapshot, little table of some type of examples of what geometric probability is. Here's some examples, a sample space, what the sample space would be. So for this segment AD, all the points on segment AD would be the sample space. An event will be the points that are on BC. Okay, so the probability of landing on BC would be the distance of B to C over the distance from A to D. So those are the things we're going to be looking at today. Alright, so first example, a point is chosen randomly on segment PS. Find the probability that the point is on RS. Okay, so RS has a length of 5. So that probability is going to be 5 over my total distance here. So I will need to add 7 plus 13 plus 5 to get my sample space, which is going to be 25. So my probability is going to be 5 over 25, which would reduce to 1/5. So the probability that a point is on RS is going to be equal to 1/5. Right. Next example, a point is chosen at random. Find the probability that the point is not on QR. So first I need to find out what's the probability that it is in QR, which using this is going to be 13 over 25. That's the probability that it does land on segment QR. Probability that it does not is going to be 1 minus 13 over 25. Which would come out to be 12 over 25. Okay, so probability that it does not land on QR is going to be 12 out of 25. Alright, for this one, the point is chosen randomly on PS. Find the probability that the point is on PQ or QR. So I want to look at the probability that it's on PQ, or is going to be kind of our plus sign. So I want the probability that's on PQ plus the probability that it lands on QR. So I'm going to take those two and add them together. So PQ would be, say, 7 out of 25, and then this would be 13 out of 25. So if I add those two together, that's going to be 20 over 25, which would reduce. You always want to put these in lowest terms. That's going to be 4/5 would be your answer. Alright, this next one, pedestrian signal at a crosswalk has the following cycle. You walk, the walk sign shows for 45 seconds, and don't walk shows for 70 seconds. What's the probability the signal will show walk when you arrive? Alright, so if you kind of look at this as a timeline, you have walk showing for 45 seconds, and then you have another cycle where don't walk shows for 70 seconds. All right, so the probability that it shows walk is going to be your sample space, which is going to be actually the sum of 45 and 70. So that actually is 115 when you add these two together. That's your sample space. Then the amount of time that it shows walk, right, would be the 45 seconds. So this would actually reduce to 9 over 23. So the probability that it will show walk would be 9 out of 23. Right? If you arrive at the signal light 40 times, predict about how many times you will have to stop and wait for more than 40 seconds. Right, so we're going to kind of use this timeline. I'm going to redraw it here. And we have this 45 where it says walk, 70 seconds that shows don't walk, and I want to figure out what's the probability that I'm going to have to wait more than 40 seconds. All right, so I'm going to wait more than 40 seconds. So I'm going to go back this way to where 40 is, 40 seconds back. So this distance from here to here would represent the 40 seconds that I would have to wait. So when I want this probability, I want this distance from here to here, okay, which is going to end up being 30. All right, so then the probability that I will have to wait more than 40 seconds would be 30 out of 115. Okay, and then I want to figure out, if I go 40 times, just at random, how much of those 40 times, or how many out of those 40 times am I going to have to wait more than 40 seconds? So to figure that out, I take this probability times 40, times this 40, to get my answer. All right, so then when I put that in the calculator and I round it, that comes out to about 10 times. So about, out of the 40, I'll have to wait about 10 times. All right, this is a similar problem. I want you to try this one, and you can check with me in class to see what if you got the right answer. All right, now we're going to look at this probability using a spinner, or really a circle, and I have the degrees measured out for you. And we want the probability that if I were to hit this little spinner and it were to spin around, what's the probability of landing on yellow? Okay, so remember, according to this, there's 140 degrees in my event, in my yellow space. My whole sample space, though, is going to be 360. So that's going to be 140 out of 360, which reduces to 7 out of 18. Okay. Next one, use the spinner to find the probability of the point of landing on blue or red. So again, I'm going to have to take my blue, my red and my blue. I'm going to have to add those two together. So the probability that it's blue is 52 degrees, the probability of red is 60 degrees, so I'm going to have to add those two together, which gives me 112. So the probability that I get a blue or red is going to be 112 over 360, which reduces out to 14 over 45. Okay, and then the last example we're going to look at is using some area. Find the probability that a point chosen randomly inside the rectangle is also inside the trapezoid. All right, so I have this outside rectangle that represents my sample space. So if I take the sample space, I want to calculate the area of that. It's going to be 45 times 20, which comes out to be 900 meters squared. All right, then I want to take and find the area of the trapezoid, which is going to be 3 plus 12 times my height divided by 2. All right, which comes out to be 75, area of the trapezoid. And then, so if I want the probability that it's also inside the trapezoid, that's going to be 75 out of 900, which is going to reduce to 1 out of 12. All right, and the units, since this is meters squared over meters squared, these units cancel out, so it is okay to just leave it as 1 out of 12.